Good morning to all. Today we are going to discuss on finite automaton, and then if time permits, I will start the next presentation. The next presentation, which is about DFA. Okay, these topics: finite automaton, DFA, and then you have one more topic: finite automaton and regular expression. So these topics are very important topics, which comes in your second part of your unit one. So these topics, which seems to be very important, because we could expect some 90% of the questions from second part of your unit one. Okay. This finite automaton, in short, we used to call it as in what we used to in short we used to call it as in recognizer. Actually, we used to call the finite automaton as recognizer, and then the purpose of this recognizer is it used to check something in the sense it used to check the input string. So input string here, which is being referred as the source code and the keyword and the words whatever that you have used in a source program. From those keywords or the user defined words or any words, it is going to take it out, and whether it's going to check whether that particular input string is present or not. Okay, so based on that only it's going to actually generate some error reports to you. For example, suppose if you're going to make some errors like insertion errors or transposition errors or replacement errors, and then you have deletion errors. So these are some of the errors that we have. So what type of error that you're going to create during the typing of your program? So generally we commonly used to call it typographical errors. These errors which comes under typographical error actually. So these errors will be detected by this particular recognizer. Actually, it's going to take some keyword and it's going to check whether the input string is present or not. So already it used to store some n number of keywords with it. So actually, it used to compare actually. So it used to take some keyword and it used to compare with the existing keywords. And suppose if the match occurs, it will give the answer as yes. If doesn't occur, if the match doesn't occur, it's going to give the results as yes, results as no. So basically, so using this, your lexical analyzer, which is going to evaluate whatever the input that you're going to give it in your source code. So it's going to take each and every input string and it's going to check for whether that particular string is present or not. If the string is present, it's going to give the results as yes. If the string is not present, it's going to give the results as no. So that's it. So we used to call this as in what? Recognizer. Recognizer, the purpose of recognizer is for recognizing the keyword, recognizing the input from a source program. We are using this recognizer. The purpose of this is the purpose of the recognizer. So it's going to take some input program, and then that will be feed to this recognizer, and it is to check for each and every keyword present in that particular source program, and it is to compare, and then it used to give the results. And then this particular finite automaton, so these recognizers whatever that we have, these recognizers are represented using the diagrammatic representation. Those diagrammatic representation we used to call it as in finite automaton. So the recognizer that we are going to use here is finite automaton, which is going to be the diagrammatic representation. That particular diagrammatic representation, which is going to act like what? Prototype for us. Okay. So already we have discussed something in this finite automaton. Once again, I am taking this in terms of just revisions. I am taking it to once again. So here in this finite automaton, we have some two types. The two types are the first one, which is about NFA, and second one, which is about DFA. So these are the two types of finite automaton that we have. The first one we used to call it as an NFA, and the second one we used to call it as an DFA, deterministic finite automaton. Okay, so the purpose of this automaton is it used to uh, produce, or it used to give them prototype. Using this prototype, you would be able to get an idea as how your recognizer it used to work. So just by saying the recognizer, the word recognizer, we wouldn't we wouldn't able to imagine, or we wouldn't able to get an exact idea as how this recognizer it used to work. But we are going to generate a prototype here. The prototype will be in forms of what? Finite automaton machine. So using this particular prototype, we would be able to get some clear picture as how your recognizer it used to work. Okay, so it's very simple. So here we are discussing about what? Recognizer. So the finite automaton is nothing but what? Recognizer. So here in finite automaton we have two different types. The first one, which is about NFA, and then second one, which is about DFA. So this NFA and DFA, which is going to act like a prototype for us. So this particular prototype, which is going to give a clear picture, or which is going to give an visual image for us as how your finite automaton or recognizer it used to work. Okay, so these are the things about recognizer and finite automaton. And as you people know, finite means what? You'll have some finite number of steps. That's about finite. Automaton in the sense actually machine. So this particular machine with some finite number of steps, it used to evaluate, or it used to find out whether that particular input string is present or not. That's about finite automaton. With some specific number of steps, this particular machine which is going to evaluate the input. Okay, so that's the thing over here. So here we have two types, what? NFA and DFA. We have some basic differences between NFA and DFA. So the basic differences are, in NFA we used to use some symbols. Actually that must be an avoided one, but we used to use it in NFA. In NFA representation we used to use it. And then you have some repetitions of works over there in NFA. But in DFA we won't have those repetitions of work, and we won't use any symbols that's going to be problematic for us to develop a program. Okay, so actually the entire structure will be like this. The structure is, you will have a diagrammatic representation. Using this diagrammatic representation, we are going to generate a program. That particular program which is going to act like what? Lexical analyzer for us. Okay, so technically, diagrams won't able to evaluate the source code, and it won't able to evaluate the input strings. Okay, but here whatever the program this prototype is going to develop, that particular program which is going to evaluate the content. So from NFA first we used to develop DFA. From DFA we used to simulate into a program, simulate it into a program. That particular program which is going to act like lexical analyzer for us. That's why we are calling this finite automaton machine, or this particular representation, as what? Prototype. Prototype means what? A model actually. Okay, so actually the finite automaton which is not going to do the exact work, but which is going to be in representation, or which is going to act like what? A prototype for us, a model for us. So using this model we could get an idea as how your lexical analyzer it used to work. Okay, so that's the thing. So here the first one, which is about NFA. So discussing on NFA, it's very simple. In NFA we used to use two things. The first one, we used to use this symbol, the symbol which is going to be the input string, the empty string. The empty string, the symbol which is going to be like what? In forms of belongs to symbol. That particular belongs to symbol which is going to be an empty string for us. So in your NFA representation you will have that particular belongs to symbol. So that's going to be one of the things. And then the second one, the same label will be passing from one node to another node, from one state to another state. The same label will be passing from one label to another label, or one state to another state. So these types of repetitions we won't have in DFA. So we have two disadvantages in NFA. The first disadvantage is using of empty string, which is going to be in first disadvantage. So make a note, kindly, dear students, kindly make a note of these things. So suppose if you have a note and pen with you, kindly make a note or put it in your brain actually. So you'll have two disadvantages while using NFA. The first disadvantage is using the empty string or empty label in your diagrammatic representation. This is going to be the first disadvantage. And then second disadvantage is passing the same label from one state to another state, passing the same label from one state to another state. So this is going to be like an repetition of work, repetitive of work. So this is going to be the second advantage that we have over here in NFA. So these two advantages are rectified in DFA, in deterministic finite automaton, where we won't have these two disadvantages over there in your DFA. Okay, and then discussing an NFA, kept in mind, so we'll have some various circles. Those circles we used to call it as states. So actually I have asked this question in Kahoot also. So each and every circle in this diagrammatic representation, we used to call those circles as states, STATES, states. And then the arrow mark, which is going to be represented as transitions. Transition means transferring or movement. So transferring or movement from one state to another state. So while moving from one state to another state, what is the thing that's going to happen over here? So that's about the transition. So we'll have circle representation and then arrow representation, and then two more important things we used to call it as an initial state and then final state. So that's it. Just we have four important notations over here in this diagrammatic representation. The first one, which is about what states, the states which is been represented using circles, and then the transitions which is been represented using arrow mark, and then you will have the third thing, what the initial state. The initial state, the first state in your diagrammatic representation, we used to represent it with zero circle or number 1. So we used to represent it with value 0 or 1. The first circle or first state, whatever that you have in your diagrammatic representation, that particular first state will be called as what? Initial state. Okay, and then the last state in your diagrammatic representation, we used to represent it with some double circles. Those double circle representation, we used to call it as in final state. Okay, so the final state, in short, we used to call it as an F. F stands for final state, the first letter in your word final. Or else we used to call it an accepting state. The other name for final, it's very important. So other name for final state is accepting state. So already I have asked you once. So what is the other name for final state? The final state is otherwise called as what? Accepting state. And then the next important thing is the initial state, we used to call it as an S0. So always we used to draw this diagram with 0, with this first circle with 0. So this particular state we used to call it as an S0. S0 stands for initial state. Okay, that's going to be the first state of your NFA representations. Okay. Um, so and then to this diagrammatic representation, we used to pass in values. That's going to be input alphabet. For example, suppose if the keyword which is going to be main which is going to be the keyword main. Okay, so here this particular input alphabet, which consists of a set of characters, the set of characters is going to be what? MAIN. Okay, and then another example, suppose if the keyword which is going to be switch, SWITCH, and then the input alphabet, which consists of some set of characters, the set of characters is what? SWITCH, where each and every character we used to call it as in labels. S which is going to be in the first label, and W which is going to be in another label, and I which is going to be in another label, and then T, and then C, and then H. So like that, each and every character will be referred here as what? Input symbols. Okay. So and then while moving from one state to another state, we used to use a function normally. We used to call it as a go to function. So you will have those we used to have those discussion in the future presentations. Those go to functions, we used to call it as an transition function. Actually we used to move a particular label from one state to another state. For moving from one state to another state, we are going to use a function. The function name is nothing but what? Go to function. Okay. So that particular function we used to call it as a transition function. Okay, so that's it. So these are the things that we have about NFA. So so each and every word, Whenever I'm presenting something, I used to take each and every word of that particular slide, and then I will give some explanations on that. So that's why I'm explaining over here. Suppose if you have any doubts or clarification, switch on your mic and you could ask some questions if you have any questions. Okay. So that's it, and then so that's it. So these are things about what NFA, the introduction to your NFA. The next one, there are differences between NFA or DFA. So we can represent the NFA or DFA by transition graph. So already I have told you that what the diagrammatic representations we used to call it as in transition graphs, or else we used to call it as in transition diagrams. Those NFA diagram or DFA diagram, whatever may be the diagram, those diagram we used to call it as in transition graphs, or else we used to call it as in transition diagrams. And then each and every states which has been otherwise called as what, nodes. So nodes, circles and states, all these things refers to the same thing. Okay, the nodes are states, and then labeled edges in the sense the arrow. Okay, the arrow, whatever that we are going to use, those arrow we used to call it as labeled edges. Why we are calling it as labeled edges? The reason is, at the top of the arrow we used to send some value. Actually, we used to represent with some label character value. Those characters only we used to call it actually label. So actually we used to send some labels from one state to another state. That's why we used to call it as an labels here. Okay. So that's about labeled edges. That's why we used to call it as labeled edges. So you will have transition functions. So transition function is nothing but, so whatever the go to function, we used to call this function as in go to. So go to in the sense going from one state to another state, moving from one state to another state. That's about go to function. So using those function only, normally we used to move from one state to another state. Okay. So here they have given some example, like suppose if there is an edge label from state S to state T, which refers here while moving from state S and then moving to the state T. So S, which is going to be the first state, and T, which is going to be the second state, while moving from the first state to a second state. And the input label that we're going to pass here is A. So that's about the input A. So the label that we're going to pass from S to T, which is going to be A. Okay. So and then here the same symbol can label edges from one state to several different states. So the same symbol could be passed from one state to another state more than once. And then sometimes the edges may be labeled with what, the empty string, we used to call them belongs to a symbol. The empty string which is been referred with some that particular symbol belongs to symbol. Okay. So which refers, we are not passing any value from one state to another state. So to denote there is no any transition between one state to another state, we should represent it with the empty string. The empty string which is been denoted by here using the belongs to symbol. Okay. Mm, so that's the thing. The next slide, move to next slide. So this is about transition graph. Actually, in the last class we have stopped till this diagrammatic representation, I think so. So after having some explanation on this, we have stopped. So this particular diagram we used to call it as a transition graphs, or else we used to call it as a transition diagram, or else we used to call it as an NFA, non-deterministic finite automaton. So this transition graph for an NFA which is going to recognize the regular expression. So the next important concept, regular expression. So already I told you that what is, I have asked you some questions about what is the expression, and some of you have answered. Explanation, expression is nothing but the combinations of operator and operands, we used to call as what, expressions. So that's going to be the expression. So regular expression in the sense we are using some expressions here for this NFE and DFE. This particular expression we used to call it as regular expressions. And then here in these regular expressions we have some specific symbols. So each and every symbols which denotes some actions over that. Okay. For example, as here in this regular expression you have A or B. So between A and B you will have an vertical line. Okay, you will have a vertical line, and you have some nested brackets. So or you have an opening bracket, A or B, and then you have a closing bracket. and then to the top of this ERB, you will have this asterisk. So this particular asterisk which refers to what? This is going to be one of the question in Kahoot. So this particular asterisk which refers to more than one. Okay. So which refers to what? More than one. So that's the representation of this asterisk. And then the string which is going to be end with ABB. So the entire thing which is going to be actually a regular expression. ERB to the power of asterisk and ABB. The entire thing, the whole thing which is going to be the regular expression here. And then coming to this diagram, see here you have an start state, the word start which refers to, that's going to be the starting part of your transition graph. And here you have some three states, overall we have some three states. The first state which is going to be 0, the second state which is going to be 1, and then next one which is going to be 2, and the last state which is going to be 3. So the initial state here is nothing but what? The 0 state which is going to be the initial state. So for any diagram that you're going to draw using NFA or DFA, the 0 state we used to call it as an initial state, or else we used to call it as an start state. So keep it in mind, the 0 state we used to call it as an 0 state, or else we used to call it as an start state. And then you have some various transition between 0 to 1, 1 to 2, and 2 to 3. And then the last state 3, which is being double circled. Okay, so this particular double circle state we used to call it as an final state, or else we used to call it an accepting state. Okay, which denotes that's going to be the end part of the transition diagram. So next to that we don't have any transitions, so that's why we are calling that particular state as in final state. So next to that we don't have any transitions, and so with that we are going to stop our recognizing work. Actually using this representation, diagrammatic representation, using this prototype, we should recognize the input strings. So here with this diagrammatic representation, with this double circle which denotes, that's going to be the end part of your transition diagram. Okay, and then see here we have some loops here. We used to call it looping means what? Doing the same work more than once, we used to call it what? Looping. So in the regular expression, the asterisk which denotes what? Looping, which asterisk which denote looping, or which denotes more than one occurrence, more than one occurrence of the label, we used to represent it with what? Asterisk. See here in this diagram, from 0 to 0, 0 to 0 you have what? A, and from 0 to 0 you will have what? B. So you have two things, two labels moving from 0 to 0 itself. The first one is about A, and second one which is about what? B. So this is going to be actually the movement between the same state. So 0 to 0 and 0 to 0 first we are passing A, and then 0 to 0 first, and next we are passing B. So these movements, 0 to 0 movements, could be any number of time. So depends upon the requirements, or depends upon the need. Here the movement from 0 to 0 will be any number of times, and the label may be either it's going to be passing A or B. Okay, so these types of things we used to call it actually looping. The looping process which has been represented in the regular expression in terms of what? Asterisk. So in the regular expression what we have? ERB to the power of asterisk. So you may have any number of A, the vertical line which denotes what? R symbol, or you will have what? B. So you will have any number of A or any number of B. Okay, and then what is the condition here? It have to end with ABB. It have to end with, the string have to end with ABB. See here, from 0 to 1 you have A, and 1 to 2 you have B, and then 2 to 3 you have B. So so you will have any number of A's or B's, but it have to end with what? A, B, B. Okay, so that's the thing. So easily we could compare the regular expression and this diagrammatic representation. Okay, so to denote some languages, we are using what? Regular expression, and if using this regular expression we are constructing what? We are constructing a recognizer for this. So using this regular expression only, we have constructed this transition graph for that particular regular expressions. Okay, and then Okay, move to next slide, ma'am. Move to next slide. So whatever that I have explained you will be here in this slide. So you will have some various conventions in transition diagrams as double circle in state 3, which is going to indicate what we used to call it as an accepting state. Um, so and then the start state is nothing but start state which is nothing but 0. The 0 state we used to call it as in what start state. And then moving from the start state to an accepting state, we used to have one path. Okay, so whatever the path that we used to follow, using this path only we used to identify a particular input or particular strings using this recognizer. See here, the states goes to 1, it's from 0 to 1 and 1 to 2 and then 2 to 3, and then finally we'll have an ABB yeah, in this input. That's what that we have over here in this transition diagram. So from 0 to 0 you will have any number of A's or B's, and then from 0 to 1 you will have A, and from 1 to 2 you have B, and 1 to 3 you have B. So you will have what any number of A's or B's, but it have to end with what ABB. So that's going to be the condition. Then the transition table is very important thing here. See here, first we are taking the regular expression, and using regular expression we are framing the transition graph, and then using this transition graph we are going to construct the transition table. This particular transition table which used to act like an output for us. Normally we used to do some process, and we actually we need some output for that to evaluate. So this one which is going to be act like this transition table is going to act like output for us. Okay. So this which represent we are going to represent NFA by what by transition tables, and then you have this particular table which consists of rows and columns actually. So you have some various rows and you have some various columns. So in columns we used to represent various field names like states, and then the labels. So states and labels will be there in the column title, and then in the row you will have the state numbers, actually the state numbers which will be there in each and every row. So in this particular transition table we should check in a way that while moving from one state to another state, so what is the label that we are going to get. Suppose if we are getting some label, we used to specify the label in the table. Suppose if we are not going to get any label over there, that will be specified using the empty string option, the belongs to symbol option. Or just by putting a hyphen you could represent that there is no any transition between from one state to another state. So using this table we could get an idea. So from which state to which state we are moving, and while moving from one state to another state, what is the input label that we are going to get. So that's what we are going to discuss in this transition table. Okay. So see here you have some columns, the columns which consist of state numbers, and then you have what input symbols, and also you have the empty string symbol belongs to symbol. So you will have the entry for the given state and input, and then you will have the value of transition functions apply to those arguments. um, so suppose if you don't have any transitions, we are going to represent it with what 0, or else you put hyphen, or else you could represent with some the belongs to symbol. Okay. um, so this is about what your transition table, and we have some advantages over there in transition table. So we could easily find, so what is the transition that is going to happen between states. So that's going to be the important thing. And what is the input label that we are passing from one state to another state. Actually to learn that, so what is the transition that we are doing, and what is the input label that we are passing, and to learn that we are using this transition table. Okay. And then here they have listed some disadvantages. The disadvantages are it took some lots of space, or suppose the input alphabet may be large, you need some more number of states. So these are some of the disadvantages they have listed over here. But normally we are not going to take more number of inputs, or we are not going to use more number of states and then basically it's going to act like what, a prototype for us. So this particular model which gives us the output which is nothing but what, your transition table. Okay. So move to the next slide, ma. Move to the next slide. See here, this is going to be the transition table for us. So to understand this transition table, you have to have that particular diagram, the previous diagram in your mind. Okay, so that's very important. So using that particular diagram only, we are constructing this particular table. Okay, so in this table, see here, you have state number, and then you have what, at the top you have the labels. So in this transition table you have two important things. The first one is about state numbers, and next one you have three more column. The first column which is going to be with label A, and another column which is going to be with label B, and then one more column which is going to be with the empty string. So this is going to be the transition table that we have. Vinusri, kindly move to that particular NFA diagram. The previous slide, you have that particular diagram. See here, okay, start with the diagram. So see here, in this diagrammatic representation, you have what, you have start symbol, and then you have various states like 0, 1, 2, 3. So from 0 to 0 we are moving the label what, A. From 0 to 0 you have the moving label what, B. From 0 to 1 we are moving the label what, A. From 1 to 2 it's B, and 2 to 3 it's B. Okay. So have this picture in your mind. So this particular diagram representation is very very important, because using this diagram only we have constructed that corresponding transition table. Okay. So you have arrows. Those arrows we used to call it as in transition are labeled edges which represent. So what is the work that we are going to do over here, and what is the label that we are going to detect over here, and then what is the states that we have over there which detects that particular label. So using this particular diagram only, actually we have constructed the transition table. um, so see here, you have from 0 to 0 you have A, and from 0 to 0 you have B. So these things we used to call as what, looping. And then you have 0 to 1, 1 to 2, 2 to 3. So 0 to 1 which consists of A, 1 to 2 which is consists of B, and 2 to 3 which consists of what, B. So this is going to be the representation. So we're moving from 0 to 0, what is the label that we are getting? While moving from 0 to 0, what is the another label that we are getting? While moving from 0 to 1, what is the label that we are getting? While moving from 1 to 2, what is the label that we are getting? While moving from 2 to 3, what is the label that we are getting? So this will be represented there in your transition table. Suppose, see here, while moving from 0 to 1, we are getting what, A alone, but we are not getting B, and we are not getting any empty strings over there. So we used to mention that while moving from 0 to 1 we are getting so and so symbol. While moving from 0 to 1, suppose if we are not going to get that particular symbol, we used to represent that particular symbol with a hyphen or 0 or some belongs to the empty string option. You have to mention it. Okay. Okay. Go to that particular table, ma. Go to that particular table, please. Okay. See here in this table what you have, state number 0, 1, 2, 3, and at the top you have what, A, B, and empty string. Empty string which has been denoted with that particular belongs to symbol or euro, like a euro dollar symbol, euro symbol like option over there. See here, first state which is going to be what, 0. Okay, and what is the label that we are going to, first label which is going to be A. See here, under the label A, first I am denoting what, 0 comma 1. Okay, so while moving from 0 to 0 I am getting what, A, and then while moving from 0 to 1 I am getting what, A. So that's what which has been represented in this table. So while moving from 0 to 0, compare at the top you will have label A. So while moving from 0 to 0 I have A, while moving from 0 to 1 I have what, A. So that's what which has been with some nested braces, 0 comma 1. And while moving from 0 to 0 we are getting what, B. While moving from 0 to 0 we are getting B, and then you don't have any symbols, empty symbols over there, so just we have put theta over there. And then the next state which is going to be 1, while moving from 1 to 2 we are getting what, B. Okay, just we are getting a single label B alone. So that's why while moving from state 1 state 2 we are getting B. That's why under B I have represented as what, 2. So moving from 1 to 2, we are getting the label. The label is what? B. Okay, and in the next state, which is going to be 2, while moving from 2 to 3, we are getting B. So between 2 to 3, we are getting B alone. That's why under B I am representing with some nested braces what? 3. So state 2, and where we are moving state 3, what the symbol that we are getting? B. So the first column, which is going to be what? The state number, and then at the top you have what? Labels. Now we have to compare the state numbers with the labels, and then if label present, we have to denote what is going to be the source state and then destination state. So for the label B, the source state, which is going to be 2, and then destination state, which is going to be 3, and then the last state, which is going to be 3. So there is no any transitions after the 3, which is going to be final state. So here we should represent it with what? Everything with what? It with some theta. So in the last row, we don't have A, we don't have B, or we don't have any empty string. So in the last third row, we are representing it with what? Theta. Okay. So with this table, I would like to stop this session. The session will continue in the third hour. So in third hour, we have classes. So I will complete a few more slides in this PPT, and then you have one more presentations on DFA. So that will be completed in the third hour. Okay. Um, um, uh, so uh, so thanks for listening patiently. Thank you, students. If there is going to be any changes in attendance, kindly let me know. Okay. So thank you. Thank you for listening.